Morning to you all. My name is Pericles. I'm adjunct faculty at the Hellenic Naval Academy in the Department of Computer Science. Today I will be giving a guest presentation. It's a topic that I have discussed earlier in a different, in another conference. However, I have the honor to be invited by WSEAS for today's event. The topic that I will be discussing is the design of defense control vocabulary based on SKOS encoding and for information in press releases. This is the very first phase of research that has to do with formalizing information in text with respect to military events. So this is the outline of my presentation. We'll offer background, what it is, for instance, what it is that I'll be discussing, motivation of this research presented, the objective of our research, or relevant research with respect to control vocabulary, the very first step of the methodology, and the pilot results of the research. Now imagine that you would like to write a book, right, about a topic. Let's say that you would like to write a book about fruit recipes. So for that, when you have this knowledge of how to produce a fruit dish, for instance, and you would like to take it and put it in a text, what you would like to do is that you have words, and the words are combinations of characters and of numbers, or words and alphabetical characters and numbers, and they represent a spoken entity. Now, these specific words that are used in a specific domain are referred to as terms. Terms are words or phrases that describe a thing in a specific domain. Now, combinations of terms can give rise to a vocabulary. For instance, terms like avocado or glazed avocado are part of a vocabulary that is used to describe the knowledge in a field, for instance, that has to do with fruits, or in this case, in the domain of, for instance, writing recipes with respect to fruits. So the vocabulary is words employed by a language or people in a field of knowledge. For instance, apple, orange, glazed avocado, sliced pineapple, and stuff like that are part of a vocabulary that has to do with preparing fruit dishes, for instance. Now, when we collect all these information in words and terms and becomes lists of words as in a vocabulary, and we formalize it with grammar and syntax, and then we structure it in sentences and paragraphs and chapters. Then we move to the next phase of having this knowledge in a construct such as a book. So a book is something that gives knowledge or understanding, something like a knowledge base. For instance, a cookbook or a recipe book is a type of a knowledge base. Now, the backbone of a book or of a knowledge base is a vocabulary, and since it is used in a particular domain, it is called a control vocabulary. So a control vocabulary is a comprehensive collection of domain-specific terms that are used to describe knowledge within a specific field. The utility of a control vocabulary can be found as in data ambiguity between data that have a similar representation. For instance, imagine that you are that you have a database with different tables, for instance, as in relational databases, and you have information that has similar representation. For instance, Smith John R can also represent information about John Robert Smith or someone called John Ronald Smith. So in this case, a control vocabulary will help to explicitly define during information retrieval, for instance, whether you want information about Robert Smith or Ronald Smith. Furthermore, control vocabularies define characteristics of knowledge resources in a specific domain. For that reason, control vocabularies can use constructs such as called universal resource identifiers. These are type of hyperlinks that are very similar to what we know, all these URLs, for instance. And as well, control vocabularies help to support semantic interoperability. For instance, automated data exchange between computer systems can be supported by utilizing same symbols or terms that refer to the same subject. For instance, medical symbols and medical terminology as in C1 and C2 that refers to cervical vertebrae of 1 and 2 that refer to a specific location on the spine can be used to retrieve data about such a medical information, for instance, from different medical databases or disparate medical databases. And furthermore, control vocabularies facilitate integration of ontologies. Ontologies are specific representation of concepts and relations between these concepts that are used in a particular domain. So, for instance, again, if we take an example of the medical domain, a single coherent base with medical terms can be integrated as using, for instance, terms such as the wall of lysosome or lysosomal membranes and stuff like that. Moving forward, I'll be giving some examples of how control vocabularies are used, and one of the uses is to give to control vocabularies are the foundation of thesaurus or thesauri. Thesauri are concepts organized in hierarchical and associative relationships, and they also provide semantic definitions. Here I have the example of an example of thesaurus used in the sciences of astronomy, and we see that we have synonyms of, for instance, of celestial bodies that are used in this domain. For instance, the term celestial sphere has all these synonyms that have been collected by this organization and are used in astronomy. Now, control vocabularies also are used in taxonomy. Here are the backbone of taxonomies. Taxonomies are things and concepts organized in groups based on the common characteristics and differences they provide. They are a good tool, let's say, for categorizing, classifying information hierarchically. This, let's say, hierarchy of inheritance. Furthermore, control vocabularies support subject headings. They can be used as subject headings of information retrieval engines, or such as, for instance, online search engines, or archive systems. For instance, the Library of Congress uses subject headings. These are a list of terms describing subjects in information system, and they are widely used, and they are the foundation of information sciences. Furthermore, the control vocabularies are part of terminology, technical terms for proper communication between specialists of specific domains, as in health sciences and medicine. For instance, this slide illustrates the example of the International Classification of Diseases, ICD code, that is used as terminology that can be used across domains and across countries and in multiple languages to help, transmit information, collect information, analyze information, and stuff like that. And furthermore, terminologies are also used by defense organizations such as NATO, for instance, which is a collection of terms, abbreviations, and definitions within a domain. So, for instance, this slide shows that for NATO, terminology is defined as a body of terms and abbreviations together with their definitions that are used by the members of this assembly of this organization and its partners for explicit and coherent communication. And here are an example of abbreviations that are part of terminology for NATO. Now, since information exists in multiple let's say phases, and it's widely used by defense organizations. And based on the research that we do at the academy, the research for this project that I'm talking, like the control vocabularies, is motivated by the heterogeneity that's in the content of military press releases and military news articles, or articles that are produced by newsrooms. And newsroom articles are a source of social military diplomacy, biomedical geography, geographical and historical data. So we have a diverse and rich source of information that we would like to tap into. However, there is a challenge. This information is it's free text, and as free text is in a structured format, so it's quite challenging for computers to analyze this information and infer more knowledge or more information out of that. So before a computer algorithm, computer program can identify, extract, and manipulate defense knowledge and correlated information, the knowledge or information has to be represented in a formal way, canonically, that is. So the objective of this research, which is in its very first phase, is to create a controlled vocabulary of terms related, in this case, that we collect information from NATO press releases on the Russo-Ukrainian conflict. Related research that has used controlled vocabularies to formalize information in text it's within the domain of controlled vocabularies, ontologies, terminologies, and also analysis of text. Here I give 4 brief examples of publications that have used controlled vocabularies to design projects that help in information retrieval and information extraction. For instance, Roca and al. Design a controlled medical vocabulary, as in the Wozer project, to exchange patient data between disparate databases based on the medical decision logic. Giordano et al. Developed a controlled vocabulary for educational purposes, that is to classify educational resources and use best practices for that reason, as in designing curricula, for instance, college curricula. Also, Huff et al. Developed a logical observation identifier name system for universal name and codes for clinical observations. This is part of the LOIN project for data exchange and reduction of time and cost of implementing standardized interfaces. And Top et al. Also created control vocabularies to assist in the exchange of information and information retrieval from the WUR scientific publications database or archive system. So we see that control vocabularies have strongly, affect and impact on projects, especially in relation extraction, information retrieval, information extraction. Now we'll be swiftly going into the methodology of this initial step of our research. We'll be discussing the data resource, the data wrangling, and the data encoding for a project. So the resource of our data is the publicly available NATO newsroom the NATO newsroom and the NATO press office online interface for collecting information with respect to NATO activities. We specifically target NATO press releases. We're interested in NATO press releases that clearly define information about the Russia-Ukrainian conflict, especially information about Ukraine with respect to NATO relations. So we collect this information and we collect these press releases. We do some data wrangling that has to do with, let's say, cleaning data, right? And we organize this information in spreadsheets. It's very simple at this point of this research phase. We just have three basic columns of date, title, of press release, and the very first paragraph of the press release, which summarizes the rest of the content. So we work this phase with this information. Now, to better help us collect control terminologies from these press releases that not only has to do with military information but also with civil information, what we do is that we programmatically split our information, our text data, into sentences at the sentence level and then at the word level or phrase level. And then what we do is we label this information as in the named entity recognition approach. For instance, we have a sentence, for instance, and then we tag information that we're interested in as with a specific label. For instance, the NATO Information and Documentation Center, NIDC, is altogether tagged as organization. Other information, for instance, the Ukrainian frigate, for instance, is labeled as edges or arms or civil or research instrument. And that's how we do our labeling system in of our data. Then we devise a classification scheme that help us classify, the wealth of information that we have collected, and it's basically a multi-hierarchy classification scheme that has a very top concept. And then as we narrow down into the information that we find in our text, in our press releases, we have three intermediate levels. So you see that the dashes show the granularity, the levels of granularity of our classification scheme. And then we move on with the formal representation of the data. For the data encoding, we use technologies of the semantic web. The semantic web is the W3C, the World Wide Web Consortium, is an international organization that creates technical standards and guidelines for web technologies. Specifically, we use the Simple Knowledge Organization System, which is a data model for sharing and linking knowledge organizations between organization systems through the web. This phase of the project, we use specific elements of the SKOS vocabulary, such as concepts, labels, relationships, and nodes. And the interesting thing and the very helpful thing about the SKOS is that it is associated with the Research Description Framework schema. This is the RDF schema. RDF is a triple, is a subject, predicate, object triple. RDF triples are building blocks of ontologies. And as such, the RDF ontologies, the RDF triples provide foundation of ontologies, and based on the triples, we can do descriptive logic inference and other logical techniques and logical, let's say, calculations. Now, terminology in SKOS, as it is defined in RDF data, eventually is also an ontology. So SKOS can also be used as an ontology and then extract and then used as a tool for logical inference and the like. Now, the way that we use SKOS and based on our classification schema, the representation of our data can be in a tree-like illustration. Here, I give an example of information. I'll go from the bottom up in reverse order, if you like. So, for instance, I have in my press releases, in the data of my press releases, the term Euro-Atlantic Disaster Response Coordination Center, which is classified, which is labeled by the term organization. This is something that we have devised through our research, through our analyses, which is part of the term assembly, which is part of the term security alliance, which is part of, the class security alliance, which is part of the umbrella class or concept, if you like, NATO. So this is how we classify our data to give it a formal structure, formal hierarchical structure. And all these terms from NATO all the way to the Euro-Atlantic disaster to the narrower term, I'm sorry, all this information is encoded, is formally encoded. And this is another example of a different term. Again, from the data from the bottom up, we have the term Treaty on Conventional Armed Forces in Europe, CFV, and which is classified by the terms legal instrument, all the way, working up our way up to the umbrella term, the umbrella concept NATO. Now, for our encoding and for this visual representation of the data, we use a tool which is publicly available, which is called SKOS Play, and renders the visualization of our control vocabularies. This is a great tool, and this is an example of the previous example that I showed you as encoded by this tool. If you notice, we have a tree-like structure, as I said earlier, and also we do not have links between the terms, and this is because this is not like a network of terms per se, but is encoding, formal encoding of terms and classification scheme. So that's why we do not present links between terms belonging to different classes. This the other example, the other visualization of the other example that I used, and the pilot results show us that we have analyzed the first paragraphs of 422 NATO press releases with respect to the Ukraine, with the subject, with the main subject Ukraine. We encoded our data with the SKOS schema. We have one top concept, as I said, which is the umbrella concept term, which is NATO, and below that we have 1,441 other concepts. We have 149 unique definitions as extracted from our classification scheme, 65 unique broad concepts, and 1,446 unique narrow concepts, which are part of our text data. This is some more information about the label schema that we have. Since I said that we have three levels of hierarchy, the first level, right below the umbrella term, has 10 labels. In the second level, we use 19 labels, and level 3, as it is now in the pilot phase of our project, we have 35 labels. These are also due to editing, and it's an ongoing process for editing the labels and finding the best for representing our data. But we also use a multi-level hierarchical classification system that helps us to, if needed, to tag information at a very narrow, as it comes out of our data, out of the press releases with higher level classes. And the next step of this project is to encode additional data and then have a comprehensive statistical evaluation for classification scheme. Thank you. And